Okay, today we are going to discuss on how to check IGBT, insulated gate bipolar transistor, using our multimeter analog. Okay, we have here four different types of IGBT. First, we are going to check this one, but before checking, we need to research or check the internal schematic diagram of a certain part. So I already have this. So this is your number 1, 2, 3, and 4. So number 1 will be our source and also your 4. Number 2 is the gate. Number 3 is the drain. So first, in checking, we need to charge first the capacitor inside your IGBT. So in order to charge it, we need to put our positive probe to our source and your negative probe to our gate. So in the tester, it should not have any reading. So after that, we will check the forward and reverse bias of our source and the drain. So both should have a reading. See? Okay. Now, in discharging, we need to put our negative probe to our source and your positive probe to your gate. So we should not have any reading on our multimeter. So now we'll check the forward and reverse bias of your source and your drain. So forward bias should have put your negative probe to your source and your positive to your drain. Should have. So this, since that is forward bias. Now in reverse bias, once we put our positive probe to our drain, this one should not have any reading. Okay? So I will drain first. Again, drain. So see, we don't have. And then in forward, should have. Reverse. As you can see, reverse should don't have. Okay? Now we are finished with this. Now we will check the other one, this one. If this means it is good. We are having a good IGBT. Now let's check the other one. As you can see, upon charging our gate, our capacitor inside, we already have reading in our tester. So it means that this IGBT already have issue. So it means this is defective. So if in case we don't have getting any reading, and then we are going to charge the capacitor inside. So shall we say this is not moving. Once we put here, you see, we have, once we discharge, you see, still have forward and reverse bias. So this is defective. This one is a good. So again, I will charge this by putting the positive probe to your source and your negative to your gate. Forward, reverse, it should have. And then once we drain, okay, forward bias. Forward bias should have, and reverse shouldn't have. Okay. Okay, see, we don't have. Okay, now let's proceed to the next. So this is another type. So still, you need to search the pinouts. So 1 will be the gate, 2 will be the drain, and 3 will be your source. Now I will charge from, I put the positive probe to our source. So the source will be pin number 3. Okay, pin number 3, and then the gate will be pin number 1. And then we'll check the drain and the source. Forward and reverse should have. Okay, and then in draining, we need to put negative to our source, which is pin number 3, and the gate gate is pin number 1. Okay, still it should not getting any reading from the tester when we charging it, discharging. So forward, reverse, okay, forward there is, reverse don't have. So this means it is a good transistor. Now how about this? So again, we will make charge of your gate, and then the source will be your pin 3. See, we already have a reading. So we will not continue this since this is already a defective one. Okay, thank you.